In our last section, we studied complex numbers, and we converted them from rectangular form to polar form, and then back again. Well, there's another form of complex numbers, and it's called the exponential form of complex numbers. And it takes us a lot of places and allows us to do a lot of things. In this section, we're going to see the relationship between complex numbers in rectangular form versus polar form versus exponential form. And specifically, we're going to learn how to express a complex number from rectangular to polar to exponential, and then back again from exponential to polar to rectangular. So it really is learning the language of complex numbers. A complex number in polar form is given like this: r times the cosine of theta plus j times the sine of theta. But in exponential form, a complex number is written as r e to the theta times j, where theta here in this statement must just be expressed in radians. This r value right here is the same as this r value right here. So this r of 2 and that r of 2, same kind of thing. If it was a vector, I'd get it by using the Pythagorean theorem. And it is a vector, but I mean if it was in rectangular form. So really, all I have to do when a complex number is in exponential form to get it into polar form, all I have to do is to take this value for theta, which is in radians, and I've just got to convert that to degrees. So the theta in this problem of 5.6 radians has got to be multiplied by 180 degrees over pi. Remember, this is radians and this is pi radians. So the radians cancel out. And when you do this multiplication, you get an answer of 320.9. And I just want you to know that that's in degrees. So the answer to this problem in polar form, to convert it to polar form, would be 2 at an angle of 320.9 degrees, or 2 times the cosine of 320.9 degrees plus j times the sine of 320.9 degrees. There's not much to this, and this particular complex number would be located as a vector about here, and the length of this line would be 2, and this angle would be about 21 degrees, which is the same thing as 5.6, and I'm just going to put down here radians. So it was this number in polar form, and this is just what it looks like in exponential form. So if I want to go from polar to exponential, all I have to remember to do is to take the 245 degrees and multiply it by pi over 180. So on my note card, I might want to write a note that said if I want to go from degrees to radians, I multiply by pi over 180 to get this into radians. Remember, if you would, please, that in the rectangular coordinate system, while this is 0 degrees, which is 0 radians, this y-axis is 90 degrees, which is the same thing as pi over 2, or half of 3-ish. This is 180 degrees, which is 3.14. This is 270 degrees, which is 3 pi over 2, or 1.5 pi. And then when you get over here to 360 degrees, you're at 2 pi radians. So this 245 degrees, which is right about here or so, its R value is 4.3. Remember, this is 3.14. This is about 3 pi divided by 2 is about let's see, 3 times pi, that's 9 divided by 2. About 4.5 or 4.7 maybe is what it is, because remember this is 6.28. 2 pi is 6.28. So 4.3 is exactly in that third quadrant. I would write this as 2e to the 4.3j is all I'm looking to have you do. If I ask you, which I will, to go from rectangular to polar to exponential, I'm just going to do a little reminder over here. A plus b times j is rectangular. Polar is my r value times the cosine of theta plus j times the sine of theta. And I'm going to put here in red that theta must be in degrees to be in polar form. And then exponential form of a complex number is r e to the theta times j, but I'm going to write in red here that theta must be in radians. And then you have what you need on your note card. So if I was working this problem and trying to get it from rectangular to polar to exponential, personally, I would draw a quick picture. X is positive 47 and y is negative about 10. So this is where that vector is. Remember, by the Pythagorean theorem, you're going to put the 47.3 and the 10.9 in to find your r value. And when you do that, by the Pythagorean theorem, you're going to get that the r value, the length of that vector, is 48.5. Your reference angle, by taking the inverse tangent of the 10.9 divided by the 47.3, your reference angle is going to be really close to 13 degrees. If you don't mind, I'm just going to round it to 13 degrees. Because you know this is in the fourth quadrant, you're going to take 360 and subtract that reference angle to get your fourth quadrant angle. So 360 minus 13 is going to give you 347 degrees. That would allow us to right now stop and just go ahead and say that in polar form, this complex number is 48.5 at an angle of 347 degrees. I'm just using the abbreviation here. To take this 347 degrees and put it in exponential form, I've got to multiply by pi over 180 degrees because these degree symbols will cancel out. When I do that, I get 6.06 radians. You could call that 6.1. And so when you write your answer in exponential form, you'd have 48.5 e to the 6.1 j power. This next one, just take it to exponential form by taking 135 degrees and multiply it by pi over 180 degrees. And if I were you, I'd stop and just do this on your own, although I've practically got it done now. And then in exponential form, the r value stays a 5 and the angle is up as an exponent, 2.36 j. We could take this to rectangular form and you'd take 5 times the cosine of 135 and 5 times the sine of 135. There's never going to be a reason or a need to put your calculator in anything but the degree mode in this chapter, even though we're working in radians, because I'm just go ahead and converting from degrees to radians this way. So I don't need to mess with that. Go ahead and do this problem, if you would, please, on your own. Use the Pythagorean theorem and inverse tangent to get this into polar form, and then take your angle and convert it into radians. Once you've done that, check with me and see how you did. So this complex number is to the right 6 and up 2. It's in the first quadrant. I'm just trying to get a good visual on that. My r value, by taking 6 squared plus 2 squared, turns out to be 6.32. This little reference angle using tangent is, by taking the inverse tangent of 2 divided by 6, turns out to be 18.4 degrees. So in polar form, you have 6.32 at an angle of 18.4 degrees. Next, you take your 18.4 degrees and you'd multiply it by pi over 180. I think it's 57 degrees is 1 radian, so 18 degrees is going to be a decimal less than 1 radians. And so in exponential form, I'll have 6.32 e to the 0.32 j. Again, remember this is polar and this is exponential form, and you are just learning the language so we can use it in the next section. We're going to go backwards in the next few problems, but I'm going to come back with a new segment to do that.